good morning. This video is about evaluating a function at various values. And so you have a worksheet to go along with it. I put those problems on the board. And so we're about to just remind you guys of how this went. If the last class you had was intermediate algebra, you've seen this before. You'll recall, in general, that f of x is another name for y. And it means the function at the value x. So x is the input and y is the output, or f of x is the output. It's the y value that goes with this specific x value. That's what it means in general. So for number one, they're asking us to evaluate this function. F of x is negative 2x squared minus 6x plus 3 at the x value negative 3. So all we do, and if you watch how I do this and you practice this, your answers will be correct because you won't have problems with your negatives. What I'm going to do is when they ask me to evaluate f of negative 3, see how that's in place of the x? I'm just going to go in here and everywhere there's an x, I'm going to make a replacement. I'm going to substitute in whatever value I find right there, and the value happens to be negative 3. So I'm going to go through and say, okay, negative 2 times negative 3 squared minus 6 times negative 3 plus 3. Then I will use order of operations, PEMDAS, GEMDAS, please excuse my dear Aunt Sally, BODMAS. That's what I mean by order of operations. If you've heard any one of those terms, that's what I mean. It's taught differently in different places. So if I exponents, parentheses go first, but when I see these parentheses and there's only one number in there, that parenthesis step is over. So I'm ready for exponents, powers up. So I'll take care of this. Negative 3 times negative 3 is a positive 9. So this will be negative 2 times 9. And I can go ahead and multiply this. Negative 6 times negative 3 is plus 18 plus 3. Negative 2 times 9 is a minus 18 plus 18 plus 3. The y value is 3. So what this means is f of negative 3 is 3. What this means is that when the x value is negative 3, the y value is 3. This is one point that we could find on the graph of this function. All right, let's look at number 2. I'm going to come back to number 2 because I've done this worksheet several times, and this fraction right here troubles people. So I'm going to spend a little time on fractions so that you're not afraid of them. Let's skip that for now. Let's do this one. F of x is equal to negative 7x minus 5. Find f of a. So this time they give us the x value is a variable a, not even a number. That's fine. You're just going to do the same thing. This is going to be negative 7 times something minus 5. What am I supposed to substitute in this time? Whatever I find over here in between these parentheses, and it's a. So this expression, f of a, is equal to negative 7 times a minus 5, and that's all there is to it. If we had a number for a, we could use that, but this is just substituting in a value. Let's do number 4. Let's find f of x for negative 8x minus 4. So find f of a plus 5. So f of a plus 5 is equal to negative 8 times x minus 4. What am I supposed to put in for x? Whatever I find right here. So I put in a plus 5. A plus 5. And so this becomes negative 8a minus 40 minus 4. I now can combine like terms. Negative 40 plus negative 4 can become negative 44. So f of a plus 5 is equal to negative 8 minus 44. All right, let's tackle number 5. Number 5 goes like this. F of x is x squared plus 2x minus 6. Find f of a plus 2. So, right here, f of a plus 2 is going to be, okay, I'm substituting something in for x wherever I see it, so it's going to be something squared plus 2 times something minus 6. And the something that's going in for my x is never a mystery. You always just look and say, what am I supposed to be putting in? And a plus 2 is what I'm supposed to be putting in. So I say a plus 2, a plus 2. All right. Now we use order of operations to evaluate this. Parentheses, we have parentheses, but there's only one thing in there because a plus 2, these cannot be combined, so there's really no work to be done inside the parentheses. Next step is exponent, so we need to square a plus 2. So a plus 2 squared turns into a squared plus 4a plus 4. And so many times students will incorrectly say that a plus 2 squared is equal to a squared plus 4, and they will not have this middle term. That is completely wrong. And so if that is what you tend to do, you should take a plus 2 squared and expand it into a plus 2 times a plus 2, because that's what something squared does. Then carefully multiply this together. A times a is a squared. A times 2 is 2a. Then we're ready for this term. 2 times a is another 2a, and 2 times 2 is 4. Combine like terms, 2a plus 2a is a 4a plus 4. That's what you get when you square this term. So you need to be careful about that. Then we can go ahead and distribute this 2 to both terms. So this is plus 2a plus 2 times 2 is 4 minus 6. Lastly, we'll go through and combine like terms. I have a squared, 4a plus 2a, these are like terms, gives me 6a. Then I have a 4 plus a 4 minus 6. 4 plus 4 is 8, minus 6 is 2. This is what f of a plus 2 equals to. All right, let's do 6. This will be pretty straightforward. F of x is equal to x squared plus 3x minus 5, but we are supposed to figure out what f of 3a is, so we'll do the same exact thing. We'll say f of 3a is equal to something squared plus 3 times something minus 5, and what we're supposed to put in there this time is 3a. So we go through and we say, okay, 3a, all right. This, if you remember your exponent rules, when something's being raised to the power, everything gets the power. So this is an exponent rule. Suppose you had a times b raised to the nth power. This is equal to a to the nth power times b to the nth power. Because currently the power on the a and the b are 1. So when you say a power raised to a power, it gets multiplied. 1 times n. 1 times n. So if we look at this, 3a squared, this is 3 to the 1, a to the 1, and they're being raised to the second power. So this is really 3 to the 1 times 2 power, or 3 squared. 3 squared is really 9. A to the 1 times 2 would be a squared, plus 3 times 3 is 9a minus 5. This expression right here is what f of 3a is equal to. All right, so that's everything except for the one with the fraction in it. So now let's have a look at that one and figure out how to do this one. So let's go up here and say, let's evaluate the function h of t when t is equal to 4/3. Okay, so let's do that. So I'll just do the same thing. H of 4/3 is equal to negative 16 times something squared plus 33 times something plus 10. Okay, what is the something I'm supposed to plug in? Whatever I find right here. So 4/3 is what's going to go right there. 4/3. 4/3. Okay, so right here we get negative 16 times. Okay, you can use the same exponent rule that we learned earlier in maybe intermediate algebra. If we have a over b to the nth power, everybody gets the power. A is to the 1, b is to 1. So this becomes a to the 1 times n over b to the 1 times n. The same thing will happen here. This becomes 4 to the 1 times 2, or 4 squared 16 over 3 to the 1 times 2. 3 squared is 9. Plus 33 times 4/3 plus 10. Okay, so now I know you know how to do this, but I'm just going to remind you how to do fractions in case you have forgotten. when you multiply fractions, that is the easiest thing you get to do with fractions. So if I'm multiplying a fraction, a over b times c over d, you just multiply the numerator straight across, a times c, and you multiply the denominator straight across, b times d. That's multiplication of fractions. Okay, so let's see. That's what we have here, only negative 16 doesn't look like a fraction, but any whole number can be divided by 1. You can write that over 1. Any whole number can be divided by 1. So I can take 16 times 16 over 1 times 9. Now, I'm going to use my calculator to multiply 16 times 16 because I don't know what that is. Let's see. 16 times 16 gives me 256. So we'll have a negative 16 times 16, or negative 256 over 9 plus, right here, if I want to simplify a little bit, I can. I can say 3 goes into 3 once, and 3 goes into 33 11 times. Then I'm just multiplying 11 times 4, or 44 over 1 times 1 is 1, plus 10. Now, we get to adding fractions. So I know you've seen this before, but just in case, when you add or subtract fractions, you have to have a common denominator. So if I've got a over b plus c, if I'm going to add these have to have the common denominator of b. Then you add the numerators and keep the same denominator. Well, we have this situation where we need to add these two fractions. So the common denominator I need here will be 9. So how I get that is I say times 9 times 9, because really 9 divided by 9 is 1. 1 is called the identity for multiplication, and it's what you're always allowed to multiply something by. That is legal in math. Multiply something by 1, or right here, divide something by 1. That is what is okay. So 44 times 9 is 396. Okay, so this is 390, I wrote that wrong. 396 over 9, negative 256 over 9 plus 10. So we'll deal with this 10 in a minute. This is 10 over 1 if we want to write that. If we want to get a common denominator, we could say times 9 times 9, and that would give us 90 over 9. So let's just go ahead and do that. 396 minus 256 plus 90 gives me 230 over 9. And so that is what I got. So what does this mean? This is what h of 4/3 equals to. And so that means that when the x value is 4/3, the y value is 230 over 9. Now, quickly, or this won't take too long, on the back of your worksheet, let's deal with that. On the back of the worksheet, I've given you 3 graphs that I'm not going to do the whole thing. I'm going to go through one with you, and then you can complete the rest. But we discussed topics like domain and range and point plotting. Now, point plotting is a really good way to get a feel for what a graph will look like. And so what I've given you on the back are some suggested x values. Now, these are not always the x values that you will need, but usually it's a good place to start. So what I chose was, and I just selected these. These are not, sacred or in stone. These are just some. I said, let's just see if we can see what our graph looks like. So let's try these x values. So on the back, I have the first problem is f of x is equal to the absolute value of x plus 2. And so this is the x values that I selected was -2, -1, 0, 1, and 2. And by selecting these, what I'm asking us to do is do what we did on the front part of the sheet, is evaluate the function for these x values. And so this is what f of x equals to. So let's just plug this in. The absolute value of -2 plus 2, what does that give us? Well, absolute value is a distance. It means how far is a number from 0. So when you take the absolute value of a number, you ask yourself, well, how far is this from 0? Like on a number line, right? So here is 0, and here is -2. And so you say, how many units is between here? And there's 2 units between there. So the absolute value of -2 is 2. So this is 2 plus 2, which is 4. What that means is that for this function, When x is -2, y is 4. Okay, let's go through and do -1. The absolute value of -1 plus 2. -1 is 1 unit from 0, plus 2 is 3. That means when x is -1, y is 3. There's a second point for our function. The absolute value of 0. How far is 0 from 0? It is right there. It's 0 units away. So when x is 0, y is 2 for this function. The absolute value of 1 is 1. The absolute value of 2 is 2. So we get these additional points, 1, 3, and 2, 4. So what you're about to see, I gave you some grid marks. You can plot these points. Go to -2, up 1, 2, 3, 4, right here, okay. -1, 1, 2, 3, 0, 2, 1, 2. At 1, we're at 1, 2, 3, and at 2, we're at 4, okay. We get these points. That's what you should get. Now, what you're seeing is it looks alike on the same side of the y-axis, and this is some symmetry. The y-axis symmetry is what you're seeing. So, for an absolute value graph, how do you connect these dots? You connect them with a straight line. So, this is what an absolute value graph looks like. It looks like a V shape. It's a V-shaped graph. Here's the caution I will give you. For the other two graphs that I have on here, number 2, x squared minus 1, this is a parabola. So you're going to get a set of points like I did here at 5 points. When you connect those, you want to connect those with a smooth graph. Not a line, but a smooth graph. And then number 3, f of x is equal to 2x minus 3. That particular function is a line. You can, if we replace f of x with y, you would hear y equals 2x minus 3 or y equals mx plus b. You can kind of hear that. That is a linear function. How you can spot linear functions is lines. How you can spot them is the highest power of any variable will be 1. And so that's how you can recognize a line. So this was this one. What we have left to do is talk about the domain and the range. So domain, what is it? Domain in general is what are the x values allowed to be? What are the x values? So here is my function box right here. Here's some function f. What we put into a function is the domain or the x values. And what we get out of the function is called the range or the y values. And y is also known as f of x. So right here, these were domain values. These outputs are range values. When you have a graph, it's super easy to just tell what the domain and range is. You just read the graph. So for domain, what I'm looking at is left to right, because that's my x values, left to right. You ask yourself, how far to the left will this function go? How far to the right will this function go? So when I look at this, I see arrows. This will go on forever. See, I just chose these 5 points. There are an infinite amount of points we could have selected. So who's got time for that? So I just chose a few. So right here, left to right. How far to the left will this guy go? It's going to go as far to the left as it wants over time and eternity. So the domain for this is from -infinity. So I am using interval notation to write this. From -infinity, and you don't ever put a bracket on an infinity symbol. They always get parentheses. And then it's going to go here, and it's going to keep going, and it's going to go as far to the right as it wants to go. So this is to positive infinity. That's the domain of our function. When we talk about range, I'm also going to be using interval notation, and you use interval notation to be able to write down an infinite amount of points. If we just needed to make a list, we could just list them, a number, comma, a number, comma, a number. But when you have to write an infinite amount of points, and that happens whenever there's like a solid line in between something, you have to use other methods. And so interval notation is a nice way to do that. So the range is the y value. So you look at your picture and say, well, where does my graph start? There's nothing, nothing, no graph, no graph. And this point right here is the first place that I see a point. That y value is 2. So it's going to go from 2 to infinity. The range is going to go from 2 to as high as it wants to go. Now this is important. What do I put on the 2? Because this is not an open circle but a closed circle, means it's defined there. It gets a bracket. So the range is from bracket 2 to infinity. Okay, so go ahead and finish the rest of the sheet. Figure out the y values, plot your points on there, connect the dots, and tell me what the domain and the range are for those. Awesome.